Hello students. Now in this video we are going to use the concept map, which is an easy memory tool for the chapter electric charges and fields. Now when you talk about charges, either they are positive or negative. And for this you know the concept of quantization of charges. Q is equal to plus or minus NE, where N is the number of electrons. Either you remove an electron, it becomes positive, or you add an electron, it becomes negative. These are the two possibilities you have. But it should be an integral multiple, whole number. It cannot have in between numbers. It should be only whole numbers 1, 2, 3, 4. N takes the values of whole numbers 1, 2, 3, 4 and it can go till infinity. So you have quantization of charge which says Q is equal to plus or minus NE. From there, charges, we move to Coulomb's law. What Coulomb's law states? It talks about the force between two charges. We have two charges Q1 and Q2, and the charges can be positive or negative or both positive or both negative, separated by a distance R. Now there is a force. You know, like charges, positive positive, negative negative will repel, and unlike charges, positive and negative will attract. So the force is given by 1 upon 4 pi epsilon naught into Q1 Q2 upon R square. R square is the distance, it is inverse square law. The force decreases in terms of the square of the distance, and epsilon naught is a constant called permittivity in free space. Now we can express this in vector form in very easy way, because force is a vector quantity. So F vector is equal to same 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Put a R cap there, which is a unit vector in the direction of either the force or the displacement. That's a displacement vector. Now when you keep it in a vacuum, Coulomb's law is epsilon naught, we use it. But if you place it in a medium, if I take two charges, two charged bodies and place it in a medium, let us say water, then what will happen to the force? Force in the medium will be 1 upon 4 pi epsilon. It is here epsilon naught and it is epsilon. Epsilon is permittivity of a medium, in a medium. Okay. Now, otherwise everything remains the same. Now, what is the relation between that epsilon naught and epsilon which is in free space and in a medium? What is the relationship? And that relationship you can obtain by this F naught upon F medium you get epsilon upon epsilon naught, which is K. K is called dielectric constant, a constant, dielectric constant. For water it is 81. Now remember, K is equal to epsilon upon epsilon naught, and we can get also force in a medium is equal to F naught upon K. The K value is in the denominator, so the force decreases. So you can use this in numerical. For example, for water, K is 81. Now from the force point, now we move to electric field, the second point. Electric field is force acting on a unit charge. The unit charge is taken as a positive test charge. On that, what is the force acting in a particular medium surrounding, and that is called electric field, like gravitational field. Now electric field of a point charge, you take only one single charge, and on what is this area which is going to be the space, the sphere of influence, then electric field is equal to 1 upon 4 pi epsilon naught into the charge Q upon R square. Now, this is electric field. Generally, we talk about the point charge. Now, we have a concept called dipole. Di means two. Two equal and opposite charges separated by a small distance 2a, and that is called the dipole actually. Now, why is it 2a? It is convenient for numericals. You can even take it as simply a or r, anything as you wish. Right. Now, what is dipole moment? Dipole moment is represented by P is equal to Q into 2A. Dipole moment is a vector quantity and its unit is Coulomb and distance is meter, Coulomb meter. Now, dipole is a very interesting concept. Dipole, you need not worry much about it. A simple hydrogen atom you take here, it's a dipole. Hydrogen atom has a positive nucleus and an electron is revolving around it. Fine. And separated by a distance, there is no connection actually. It is only a force of attraction, right? Electrostatic force. This is only, we have drawn this line axis for a reference. Otherwise, there is no rod or anything here, right? Hydrogen atom is a simple dipole. Two equal positive charge and electron revolving around it. Separated by a small distance, you know that it is going to be in terms of 10 power minus 15 or so. Now, we move on further. It's not 10 power minus 15, 10 power minus 10. Armstrong unit it will be. Now, when I take this dipole and place it in a electric field, uniform electric field. Uniform electric field is, you can see very clearly, parallel lines are going. And I place a dipole here, equal and opposite charges separated by a distance 2a. Naturally, when you keep it in an electric field as one side is positive, other side is negative. So this positive charge will experience a force and negative charge will experience a force in its opposite direction. So what will happen with respect to this dipole is not going to move in the translatory way, no translatory motion. Why there is no translatory motion? For that the point is, if the two dipole is here, a force is acting here and a force is acting here, the axis of rotation is not, the line of action is not same. This force and this force are not acting in the same line, but you see it is acting in opposite ends of the line, so it sets up a rotatory motion. So remember, in the case of a dipole, no translatory motion as net force. QE gets cancelled, plus QE in minus QE, and only rotatory motion. And rotatory motion will set up a torque. Remember, rotation, it will set up a torque. Keep that in mind. So what is the torque produced? Force multiplied by the perpendicular distance, and you do the calculation, tau is equal to PE sin theta. You know sin theta is referred to the angle between the electric field and the dipole axis. So this is a vector quantity and it's a vector product, and tau is equal to P cross E. P vector cross E, where P is equal to Q into 2A. I hope you understand these points here in this area. Now from here, I move on to electric field due to a dipole on axial line. See, this is the axis. Dipole is there. This is the axis. And in this axis, I choose a point P and find out what is the electric field at that point P. Now at this point P, the electric field is due to positive charge and due to negative charge. Positive acts outward and it is close here. So naturally the force electric field is stronger here, and negative is far away. So the force electric field is less here. So naturally E plus is more than E minus, greater than. Again we said that O is the center point of the dipole axis here, 2a is the distance between them, and r is the distance of the point P we have chosen with respect to the dipole axis middle point. So you do the calculation. It's a concept map. I am going to be very short in this. You can watch my video, full detailed video. Now electric field due to the dipole in an axial line is 1 upon 4 pi epsilon naught into 2p upon r cube. Keep in mind, it is dipole, and so you have 1 upon 4 pi epsilon naught 2p upon r cube. Electric field due to a point charge, PC is point charge, is proportional to 1 upon r square. You studied here Coulomb's law, 1 upon r square. But here it is going to be for a dipole 1 upon r cube. Keep that in mind. Now electric field on a equatorial line. Equatorial line is nothing but a perpendicular bisector. This is a perpendicular bisector. How these two charges are going to act on that you have to study. A dipole. Again, a dipole is two equal and opposite charges separated by a small distance we have taken as 2a. Now the middle point of the dipole axis is 0. O. And the point P is on the equatorial line. Now the distance between point O and P is r. Right? Again you further do the calculations. Due to the positive charge, electric field is outward, E1. And due to negative charge, electric field is inward, and that is E2, right? And the net electric field, E, the net electric field using parallelogram law of vectors turns to be in this direction, and theta you can take it to be 60 degree if it is equilateral triangle. So E is equal to 1 upon 4 pi epsilon naught into P upon r cube. Carefully check the difference here. E on the axial line is 1 upon 4 pi epsilon naught 2p upon r cube, and E on the equatorial line is 1 upon 4 pi epsilon naught p upon r cube. There is a 2 here and there is no 2 here. So I can make a small connection here. I have written, right? It's gone little out of the focus of camera. So E axial is equal to 2 times E equatorial. So this is the whole process, the concept map which explains to you about electric charges and electric fields. I hope it will be helpful to you. These are all created for the students who are appearing for NEET examination. I will try to do as many concept map as possible and as quickly as possible, so it helps you in your 2022 examinations. The next concept map will be based on electric flux and Gauss theorem. Thank you so much.